Hello, guys. How are you? Hope that you are all good and safe. Today, guys, we're going to explain the relation and we're going to know how to make some calculations about the mole and molar mass. And as we mentioned before in the class, that the molar mass is the mass for 1 mole. This is why we called it molar mass, because it's only for 1 mole. So, for example, when we're talking about oxygen in the periodic table, the mass number is 16. This is the mass of 1 mole of O, and not O2, only O. Because as we said before, the mass number in the periodic table is the average measurement of the masses of all isotopes known for the elements. But if we're going to talk about the molar mass for oxygen as a gas in nature, we know that oxygen found in nature in a form of O2. So the molar mass for O2 will be 32, which is 16 times 2. Because here we are talking about a molecule made of 2 atoms of oxygen, diaromic molecule. Okay? But for example, if we talk about like copper, for example, it is 63.5. And copper is found in nature in a form of individual atoms like Cu, not molecules. So the molar mass for copper as an element will be the same, which is 63.5. Now, what about, for example, like a compounds like water, H2O? For water here, we have 2 hydrogen atoms. So the total mass for hydrogen will be 2 times 1, which is 2. And oxygen, we have 1 atom of oxygen times 16, which is the mass number for oxygen, 16. So the total mass for water will be 18 grams per mole. Gram per mole, this is the meaning of the molar mass, which is the mass for 1 mole of the substance. For example, if we talk about like NaCl, the molar mass for it is the molar mass of Na plus molar mass of Cl. 1 atom. So it's gonna to be 35.5 plus let me just check about molar mass for sodium. I think 22 or 23, 22.99 actually. So it will be 23. So the molar mass for it will be 85.5 gram per mole. So when we talk about molar mass for an element, we are talking about the total mass for this element. If it is a metal, for example, which will be found in nature in a form of individual atoms, so the molar mass will be just the number from the periodic table. If we are talking about diaromic molecules like Cl2, N2, H2, F2, the molar mass for it will be times 2 from the periodic table times 2. If we are talking about the compounds like H2O or an ACl, the molar mass for the compound will be the sum of all atoms in the compound, and so on. Now, what is the relation between the molar mass and the mole? As we said before, 1 mole is equal to the molar mass, which is, by the way, we can make this relation as a triple relation. We can connect it with Avogadro's number as mentioned before in the class, which is equal to Avogadro's number. So when we say that 1 mole, for example, of Fe is equals to 6.022 times 10 to the power of 23 atoms of Fe, the mass of Avogadro's number of atoms of Fe is equal also to the mass of the 1 mole of Fe. Sorry, this is fluorine, which is also the molar mass for iron, as you can see here, which is almost, you can see, 56. So the 56 gram here, it is the mass for 1 mole, and at the same time it will be the mass of Avogadro's number of iron atoms. So this is how, guys, we connect the three terms together. Now, what about some calculations? For example, first, what is the mass of, let's say, 2 moles of the following? First, Fe. Here, guys, we can form like allow to connect the mass with the molar mass with the moles, which is moles number equals mass over molar mass. By applying this law, simply we can say moles. Now, the mass is unknown, number of moles is given, and the molar mass will be known also from the periodic table. So moles equals mass over molar mass. Number of moles is 2 from the question, equals mass unknown over molar mass, as we figured here from the periodic table, is 56. So simple math, mass equals 112 gram. This is the mass of 2 moles, which is reasonable, guys, because if the 1 mole mass is 56, so the 2 moles will be 2 times 56, which is 112 grams. Number 2, let's take another example. For example, same question. What is the mass of 2 moles of, for example, H2O? Here, guys, H2O, we have to know that the molar mass, we have to calculate it first. That here we have 2 hydrogen atoms with 1 oxygen. So hydrogen, as mentioned before, is 2, because we have 2 atoms, and oxygen is 16. So 2 plus 16 equals 18. This is the molar mass for water. So same thing, moles equals mass over molar mass. Moles given, which is 2, equals mass over 18. So mass equals multiply 36 grams. Now, what if the mass is given and we have to find the moles number. For example, how many moles? There is in, let's say, 54 gram of H2O. Just apply the law. Moles equals mass over molar mass. The mass is given 54 gram over the molar mass of water as calculated before 18. So we will have 3 moles. And that's it. Now, what if we're gonna to connect the Avogadro's number with the mass? As we said, we can use the conversion factor 6.022 times 10 to the power 23 over the molar mass, or the molar mass over 6.022 times 10 to the power 23. Two conversion factors, both of them equal 1 because they are equal. So, for example, remember guys, that the conversion factor itself, it depends on the questions. The question is the main factor that going to affect which conversion factor we should use. So remember that number of atoms or molecules means that in the conversion factor we have to use Avogadro's number. And mass means that we have to use the molar mass. If we have number of moles in the question, means that we have to use the mole, which is mole over 6.022 times 10 to the power 23, or 6.022 times 10 to the power 23 over 1 mole. Or even we can use the mole with the molar mass, so it will be 1 mole over the molar mass, or molar mass over 1 mole. And we can use these conversion factors also actually to solve the previous questions here. It will be the same thing. So for example, if we're gonna to use, if we have the moles and we need to find out the mass, we just multiply the mass with this conversion factor. If we need to find out the mole number. If we have the moles number and we need to find the mass for the compound, we use this factor because the mass is unknown, so molar mass will be numerator as mentioned before in the class. So let's take an example for this. How many atoms of, let's say for example, Fe there is in let's say 26 gram of Fe. The question asks about how many atoms. That means that here we have to use Avogadro's number. And the given is mass. That means that we have to use molar mass. So what is the relation between Avogadro's number and the molar mass? And remember, the unknown quantity must be numerator. So how many atoms? So Avogadro's number must be numerator. So Avogadro's number over molar mass, which means 6.022 times 10 to the power 23 over the molar mass for iron is 56. Simply times the given quantity here, 26 gram. Here we have a gram. Gram again with the gram. So the answer will be 6.022 times 10 to the power 23 times 26 over 56. 1, and this is 2. So the answer will be 3.011 times 10 to the power 23 atoms of Fe. And if you guys here going to evaluate your answer, notice that this value is half of Avogadro's number. It is exactly the half of the Avogadro's number. And also the mass given in the question, which is 26 gram, it is the half of the molar mass. So if we have the half of the molar mass, that means that we have half mole. And the number of atoms in half mole is exactly Avogadro's number over 2. It is the half. So that means that our answer is correct. This is the evaluation of our lessons, of our question, sorry. Now, let's talk about the other point. If we have the mass, the atoms number, and we have to, for example, find the mass of it. So, for example, what is the mass for one atom of the mass for one atom of, let's say, Na, sodium. As mentioned before, and as we said, the given is atom, and the question asks about mass. So, mass means molar mass, and number of atoms mean Avogadro's. So the conversion factor should connect Avogadro's number with molar mass. The question asks about mass, so the molar mass must be numerator over Avogadro's number. So the molar mass for Na is 23 gram over 6.022 times 10 to the power 23. Remember that the molar mass is the mass for 1 mole, which is Avogadro's number. Now you could say, okay, say about that the unit for the molar mass is a gram per mole. Why we wrote it as gram only? We can say that, okay, this mass is mass gram per mole. And also this number is number of what? Atoms also per mole. So simply this mole with this mole. So we still have a gram over atoms. Now let's go back to the question here. For one atom, the question, the given here is one atom. So times one atom. So atom will be gone with atom. So the answer will be 23 gram over 6.022 times 10 to the power 23, which is 23 over 6 times 10 to the power minus 23, which is almost, let me say, almost it will be 3.9 times 10 to the power minus 23, almost 3.9 or 3.8. So imagine, guys, this is the mass for one atom of sodium, which means that you have to put 0.0000023 zeros, then write 3 times. So imagine the extreme small size for the one arrow. Okay, this is all for our lesson today. I hope guys you get it, and I hope that you solve a lot of questions from the book or from the chapter review to be just able to solve any type of such questions. Thank you guys, and hope you all to be safe. See you later.